In this video, we'll be practicing problem solving, specifically with number lines and fractions. We'll be using a lot of equivalent fractions. With equivalent fractions, we're just taking a given length and assigning it a new name. So 2/3 we could rename as 8/12. We're maintaining the same whole, the same reference whole of 1, the same length that we had identified, and just giving it a new name. We'll also be doing a lot of partitioning. With partitioning, we're taking a given length and subdividing it into equal-sized parts. Here, we could take our given length and subdivide it into 2 equal parts or into 4 equal parts. And in this case, our parts are the spaces on the number line. Let's start doing some examples. The first several examples, our task will be to determine the value of x given another point labeled on the number line. So here we have 2/7 and x way over to the right. Our first strategy is going to be to iterate, to repeat over and over the same length. So here I can see that 2/7 is 1, 2, 3, 4 spaces. So if I went another 1, 2, 3, 4 spaces, I would have gone another 2/7. 2/7 plus 2/7 is 4/7. If I go another 4 spaces, then I've gone another 2/7. 2/7 plus 4/7 is 6/7. So x in this case is 6/7. This problem worked out nicely, just recognizing that every 4 spaces on the number line represented a length of 2/7. In this example, x is in a new location, and it turns out that even if I count 4 spaces for 2/7, and then I count another 4 spaces for 2/7, and get 4/7, I haven't found the value of x, so I need a different strategy. In this case, I'm going to use equivalent fractions. So notice that I can interpret 2/7 as 2 parts, each worth 1/7 of a reference whole. Since I have 4 spaces, it would be awfully nice if my numerator was 4. So if I could get 4 parts, then I would be able to label my number line more easily. And I can see that I can do this. So if I multiply the numerator and the denominator by 2, I end up with 4/14. So now I have 4 parts, each worth 1/14 of a reference whole. So I can just go ahead and label them. 1/14, 2/14, 3/14, and I can continue on that fashion. So I found the value of 1 space just by writing an equivalent fraction. If I keep counting up, each space is worth 1/14, so I'm keeping the 14ths in the denominator and just adding 1 in the numerator. I get to 7/14, and I notice that 7/14 is equivalent to 1/2. So in the end, x is worth 1/2 of a whole. In this next example, we now have 2/5. This is a whole different number line. It's unrelated to the previous example. And so 3 spaces are worth 2/5 of a whole, and we're looking for this x right here. This one's harder, so I could iterate. So I could have 1, 2, 3 spaces is 2/5. 1, 2, 3 spaces is another 2/5, but it's not going to line up with my x. So again, I'm going to try to use equivalent fractions to come up with the value of 1 space. Right now I have two parts, each worth 1/5 of a reference whole, just interpreting my fraction, and it would be awfully nice if I could have three parts. Why three parts? Because I have 1, 2, 3 spaces. But unlike the previous example, there isn't a whole number that I can multiply by 2 to give me 3. So I'm going to try to stay away from fractions and decimals when I'm multiplying both the numerator and the denominator by the same value. So instead, I'm going to look for a multiple of 3. So multiples of 3 would be like 6 parts, or 9 parts here. And I see that I can get to 6 parts, right? So I can multiply the 2 by 3 and the 5 by 3. And so I can rename this as 6/15. So now that I have 6/15 right there, I can count ahead, right? I have 1, 2, 3 parts are worth 6/15. So another 1, 2, 3 parts, we're going to have 12/15. Another 1, 2, 3 parts, we'll have 18/15. So I'm counting by sixes in the numerator. Here it would be nice to know what one space is worth rather than every 3 spaces. So I'm going to focus on the numerator here, the 6. Notice the denominator hasn't been that important. That's just the label of our fraction. We're really interested here in the numerators. So 6, well, if I break 6 into 1, 2, 3 equal parts, then 6 divided by 3 is 2. So we'll have 2/15, 4/15, 6/15. And I can continue counting by 2s until I get to my x. So x is 14/15. Now let's try a different type of problem. Here we're going to determine the location of the fraction. So, for example, we're given 3/8, but we already have one fraction labeled on the number line. We already have 1/4 labeled. Our strategy is going to be to find a common denominator and then build on the work that we've already done. The reason that we find a common denominator is because by having the same number in the denominator, that means we have the same size parts. And once we have the same size parts, we can essentially ignore the denominator and just focus on the numerator. The numerator tells us the count of parts, and that's really what we want to be doing. We want to be counting spaces such that we can label 3/8 on the number line. So focusing on the denominator, we can see that if we double 4, we'll get 8. So we write an equivalent fraction of 2/8. 1/4 is the same as 2/8. Now it's fairly easy to see that if we partition this length into 2 equal spaces, then each one will be 1/8, and we can find our 3/8. In this next problem, we want to locate 11/12, and we're given the location of 2/3. Here, we're going to be making use of midpoints or halfway points. Again, we'll look for a common denominator. I can see that 12 is a multiple of 3, so all I need to do is rewrite 2/3 as 8/12. So in this case, I notice that my numerator is an even number. And so if I can just partition into 2 equal parts, I can find the halfway point right here. So half of 8 is 4, so this will be 4/12. And then my 4/12 I can see I can divide into 2 equal parts. Half of 4 is 2. So now I know that one space is worth 2/12, and I can fill in the rest. Here, I'm going to need to add new hash marks. So 1 space is worth 2/12, which means that half a space is worth 1/12. So here, halfway between 10 and 12, we'll find 11/12.